Question 4 of this exercise says, on dividing x cube minus 3x square plus x plus 2, this cubic polynomial, by some polynomial gx, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. And we have to find the divisor polynomial gx. So let's call this cubic polynomial px. So when px is divided by gx, the quotient is x minus 2 and the remainder is minus 2x plus 4. So we can write this as follows. So px should be equal to gx times the quotient polynomial, and the quotient polynomial is x minus 2, plus the remainder polynomial is minus 2x plus 4. So using this relation we can find gx. So how can we find gx? Well, we take this term minus 2x plus 4 to the left side. So that gives us px plus 2x minus 4, which is the inverted version of minus 2x plus 4. So plus 2x minus 4 is equal to gx times x minus 2. So essentially what we have to do is we have to add 2x minus 4 to px and divide this with x minus 2, and that will give us gx. So what is px? So px is x cube minus 3x square plus x plus 2, and to this we add 2x minus 4, and this will be x cube minus 3x square plus 3x minus 2. So this cubic polynomial, we can divide this by x minus 2. So this should be exactly divisible by x minus 2. And when we divide it, the quotient polynomial will be gx. So let's do that. Let's carry out the long division process and divide this polynomial by x minus 2. So the divisor is x minus 2 and the dividend is x cube minus 3x square plus 3x minus 2. Now remember that the dividend that we obtained was obtained by adding minus of this minus 2x plus 4 to px. So we added 2x minus 4 to px, and this is how we got this dividend. Now let's carry out the long division process. So the first multiplier we need is x square, because we want to turn x into x cube. So x square, and this generates the terms x cube minus 2x square. Now we subtract and we get minus x square plus 3x minus 2. So now we want to turn x into minus x square. So the second multiplier we will use is minus x, and this generates minus x square plus 2x. And now when we subtract, we will get x minus 2, which means that we now need the third multiplier as 1, and that generates x minus 2, and here we get the remainder of 0. So the division process terminates and our quotient is x square minus x plus 1, and this is what the polynomial gx is. So that completes question 4 of this exercise. Okay, so question 5 of this exercise says, give examples of polynomials px, gx, qx and rx which satisfy these relations. So remember that the notation being used is px is the dividend, gx is the divisor, qx is the quotient and rx is the remainder, which means that these 4 polynomials should satisfy this relation. Px is gx times the quotient polynomial qx plus the remainder polynomial rx. So I'm just using different colors to highlight the different polynomials. So px, the dividend when divided by the divisor gx, gives the quotient qx and the remainder rx. Now we have to find examples of these polynomials such that degree of px is equal to degree of qx. So that's part 1. The degree of the dividend is equal to the degree of the quotient. That may seem quite surprising, how is that possible? Because if the degree of the dividend is m and the degree of the divisor is n, then the degree of the quotient has to be m minus n. So mostly when we see any division case, we find that the quotient polynomial has a degree less than the dividend polynomial. So what could be a possible case when the quotient polynomial has a degree equal to the degree of the dividend? Well, the only possibility is if gx itself has a degree of 0, if the divisor is a constant polynomial. For example, if I take px to be, let's say, 2x square plus 4, if I take px to be this polynomial, and if I take the divisor to be a constant polynomial 2, and if I divide px by gx, then the quotient polynomial I will get is x square plus 2. So the quotient has the same degree as the dividend, and this is an example where this is possible. So whenever the divisor is a constant polynomial, the quotient polynomial will have the same degree as the dividend polynomial. So that completes part 1. Now let's go to part 2. In part 2, we want to find an example where the quotient has a same degree as the remainder. So one way to do this is to go backward and to take examples of Rx and Qx and then generate Px from that. So for example, if we take the quotient polynomial to be, let's say, x plus 1, and if we take the remainder polynomial to be x plus 2, for example, and if we take the divisor gx to be, let's say, it has to be higher, the degree of gx has to be higher than Rx. So let's say we take the divisor to be x square. So what will be the dividend Px? So we multiply gx by qx, so that gives us x cube plus x square, and then we add Rx to it plus x plus 2. So this is our polynomial Px. So if Px is this polynomial x cube plus x square plus x plus 2, if gx is x square, then we will get qx as x plus 1 and Rx as x plus 2. So the degree of the quotient and the remainder will be the same. Now you can repeat it for many other examples. Just take any two polynomials, qx and Rx, where the degree is the same, and then assume a divisor which has a degree higher than the remainder, and then generate the dividend. So this is how you can do part 2. Now let's go to part 3. In part 3, we want to find an example where the remainder has a degree of 0, which means that the remainder is a constant polynomial. So again, we could go backward in this case. We could first assume a remainder. So let's say we assume that the remainder is 2, for example. Any constant will do. So let's take a remainder of 2. And then let's assume that the divisor is, let's say, a linear polynomial x plus 1, and let's assume the quotient to be some other linear polynomial, let's say x minus 1. So the dividend will be gx into qx, so that's x plus 1 into x minus 1, which is x square minus 1 plus Rx plus 2. So Px will be equal to x square minus 1 plus 2, which is x square plus 1. So this is an example. If I divide x square plus 1 by x plus 1, I will get a quotient of x minus 1 and a remainder of 2, which is a constant. So its degree is 0. So this is how you can do part 3. And with this, we complete question 5 of this exercise.
Hi students, being good at math is super important because it helps you do well at school, but more importantly, it opens the doors for you to the most awesome careers of the future. Having taught thousands of students, I can confidently say that every student can really excel at math, including you. So I've created something special to help you become a master of math. Go to qmat.com/leap to find out more. I'll see you there.